Let us see how to solve the homogeneous differential equations. We have seen the theoretical part in the previous video and I have shown you only one example. In this video, we will go ahead and see a few more examples to solve homogeneous differential equations. Once again, let me remind you, when do you call a differential equation a homogeneous? Whenever you don't have the RHS other than 0, nothing else will be there. It's not a function of x, it's just a 0. Then it is said to be a homogeneous differential equation, and of course this is of higher order but linear. You can see we have this order of this particular equation is 3 and linear. Why linear? Because you can see that the degree of this particular equation is 1. Hence it's a linear homogeneous differential equation of higher order derivatives. Anyways, let us see how do we solve such an equation. This is of order 3. So what is the step 1? As we have discussed earlier, the step 1, we need to express the given equation in terms of operator. That means capital D. So we know that capital D stands for d by dx. So d square stands for d square y by dx square, and d cube, capital D cube stands for d cube y by dx cube. So putting this equation in the operator form, we get d cube plus 6d square plus 11d plus 6 into y is equal to 0. Here you can write, mention capital D is equal to d by dx. Okay. Now, second step, to write the auxiliary equation. So what is the auxiliary equation? This is in the form of f of d into y is equal to 0. So consider this function f of t. Replace d by m and put this equation to 0. So we get auxiliary equation therefore will be f of m equal to 0. That is, wherever d is there in this particular function, you are supposed to substitute m. Okay, so d cube becomes m cube plus again d square becomes m square plus 11d becomes m plus 6 equals to 0. Now this is a polynomial equation in m. Okay, so we need to find the roots of this particular polynomial. Okay, you can use your calculus, but still in this particular type of problems, we expect you to show how you are getting the roots. Okay, so this is a cubic equation, so you can't find the roots directly. We have to start with trial and error method, and we apply something called synthetic division so that we can get the one of the factors, and using that we can go ahead and find the further factors. Okay. Anyways, so let us start with the trial and error method. Taking m equals to 0, we can directly tell m equal to 0. Substituting here, we get 6 equal to 0, which is not correct. Okay, so 6 is not equal to 0, so hence 0 is not a root. Next, m is 1. We have to start like this with the trial and error methods. But one should be little smart. Look at this equation. This equation has all positive signs. So if I go again with a positive number, what happens? I will never get it 0. That means the value for m with the positive value, when we put for m, will not be satisfied for this equation because it will never get cancelled. Okay, so let us try with negative numbers. So I am going to try here with the minus 1. Taking m as minus 1. What happens here? I get minus 1 the whole cube is minus 1 plus 6 times of minus 1 the whole square is just positive 1 plus 11 times minus 1 plus 6. Let us simplify and see. We get positive 6, 12, minus 1, minus 11. So you get minus 12 plus 12, which is equals to 0. And hence it is accepted. So we have m equal to 1 is one of the roots. Hence, let us apply the synthetic division. What is the synthetic division here says? Consider only the coefficients of this particular equation. Coefficients of the variable here, m is the variable here, and the coefficients are 1, 6, plus 6, plus 11, and again plus 6. Only write the coefficients 1, 6, 11, and then 6. This particular one where we got it satisfied, you can write it here. And synthetic division has a little different opposite procedure to the regular division. And here we are going to start always with 0. It's a fixed thing. So you are supposed to add here. Add here. Okay. This process is called synthetic division. Let me tell you again. So 1 plus 0 is 1. Now again you go ahead and multiply. Here is product. Multiply and this is how the cycle goes. Anyways, 1 is multiplied by minus 1. Gonna get minus 1. Again add here. So what do you get? 6 plus minus 1 is 5. Again multiply. So what happens? With which you have to multiply? Always fixed. Minus 1 only. Okay. So 5 into minus 1 is minus 5. Okay. Now again add here. So we are gonna get 11 minus 5 is equal to 6. Now again 6 is multiplied by minus 1, which is going to be minus 6, and when you add here you will get a 0. And if this is 0, that means this value it gives us the remainder. So if this is 0, that says that this particular value minus 1 is one of the roots of this particular equation. Understood? So what is the use of these numbers? These numbers are going to give you the quotient. For example, I'll tell you, see, this is a normal division, and here we are supposed to write this particular polynomial and consider m equal to minus 1 means m plus 1, and then you apply long division, you get a quotient here, and the remainder should be 0 because this is a factor. This remainder you obtain here, and the quotient are these values. Got it? So this is how you can relate the normal division with the synthetic division. Anyways, let us come back to this. Okay, so my quotient is 1, 5 and 6. You have to consider from the back to the front. This is the constant, variable with first degree, variable with second degree, and we have m here. So we can write this as m square plus 5m plus 6 equal to 0 into, of course, this is one of the factors, that is m plus 1. So the given equation gets reduced to this, where you got one factor. Now let us consider only the quadratic form and apply splitting the middle term to find the two more factors. So considering the quadratic form, m square plus 5m plus 6 is equals to 0. Okay, so apply the splitting the middle term. So 6, 2 3s is 6. So 2 and 3 will add up to give you 5. So the factors are m plus 2 and m plus 3 equal to 0. So hence this equation gives us 1, 2 and 3 factors. Therefore, putting them equal to 0, we get m equal to minus 1, m equal to minus 2 and then m equal to minus 3. These are the roots of the these are the roots of the auxiliary equation. Now based on the roots, we are supposed to construct our solution, that is complementary function, and you can see the nature of these three roots is unique roots. Okay, so unique roots, what to do, how the complementary function looks like. See, we have, therefore y is equal to c1 e to the power, this value, that is whatever the root value goes to the coefficient of the x in the exponential form, minus 1 into x, which can be written as minus x, plus c2 is a constant exponential form, and the coefficient of x will be the second value, second root, that is minus 2x, plus c3, the third constant exponential form, again minus 3x. And if you don't have a negative sign here, all these will be positives. It's something like that. Hence, we obtain the solution of this particular differential equation, the cubic differential equation, whose order is 3 actually. Okay, so, and the process, this division process, whatever we have here applied, is said to be synthetic division. For cubic equations and further, we apply this process. Okay, even for biquadratic equation also you can apply this one, so that we can find the factors easily. Got it? But always it is suggested, if it is a cubic, please confirm with your calculators whether you are getting the same values as the roots. That would be always preferable, so that you don't go wrong. Understood?